It's New Year's and the wife and them are in there, so I'm in the bedroom trying to make a quick video just to kind of show you guys a few things that I've learned before in making these wheels, generators, coils, yada yada, and maybe save you some time and mistakes. First of all, here's a coil wrapped with a coil wrapper. It's 500 turns, 15 gauge. I just have those for some pickup coils like you'd have on a generator. Here's an obha coil that I have wrapped. Here's a Rodin coil that I have wrapped. Here's a little generator that I've 3D printed. I'm going to take that out and show you the magnets here in a minute. Here's a bigger version of that one and the way the magnets are spaced. The whole video is just about what happens with the field and the different spacing of magnets. That's what I want you guys to take away here. So I've got a little pull detector here that'll tell you what pull is what here, right? So give me 1 second here. So really, when I started with just a spinning ball. You guys can see that in one of my other videos. Taking this little generator apart, so I 3D printed just a little sleeve here. It's got a bearing on the end, bearing on this end. I just got a little carbon arrow from a arrow you'd shoot out of your bow and arrow. And then I have some magnets in a circle like a rotor, so it'd just be like a generator. It'd sit in the center here, it spins, and then you have your pickup coils. Now the big thing to take here is most bigger generators. I only have one hand, so let me see if I can just stick that in there for a second. Make it be my holder. It probably won't. Whatever. Anyways, the main thing is on most generators, if you're here, you have north, south, north, south, north, south, alternating all the way around. Now this thing won't spin if you do north, south, north, south. What happens is in north, south, you have a dielectric plane here, 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 here. And if I was to switch all those around, it would just go, you know, when I run this by it, it would flip north, south, all the way around in a circle, right? But the issue is if you make something, here's what I found, this is the point I'm trying to make. You make something this small, this close with the magnets, and you can't go north, south, because then all the planes split north, south, and it evenly pushes on here and here, here and here, here and here. So what happens, and it's so small, you won't even feel it vibrate. That's the problem. Now watch what happens here. This is something that's interesting. I don't know if I have those, so get it over here away from the others. So the main thing is check this out. How do I get the right angle here? Maybe this will work. No. Yeah, try to edit this video. So look how it follows. Okay, here we go. We'll do it this way. You see it follows. Yeah, those three are north or south, and blue south. So those three are north, right? And you see how it's not flipping, and even as I get directly in line with it, it's actually pointing at the center one. That's what I want you to take away. Yeah, let's get down here. I bet you this will be a better view. So as I go around and even get directly in line with this one, it's always pointing towards that center one. Okay. Flip it over. And there's the other side. You see how it always points. Technically, you would think it would flip over and point hard at this one, but it doesn't. So this one spins half of it north, half of it south. Because if you look at just how it stays there angled, there's no split. It ain't flipping between north and south like it was the north and south. And again, it won't spin if you do it. The thing's too small. I'll spin that here in another video. Now, this ring and this ring are the same. I actually had done this for a split to kind of put it over this and see how it would affect it and move the magnets around, but really it's didn't really do much, so it was a waste. But this is what it was not a waste. Okay, this one is north, north, north. Here we go. I did do it this way on purpose. North, 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 south, south, south. So it's just like the last rotor. But watch what happens here. Hold on, let me get down here like this. Okay, we'll follow this thing. So, you see how it changes? It dips. Now let's go to where the split is. Okay. Completely stays level sideways. Here it points in. Here it actually flips in. Do you see that? That flipped. This is red over here. You see right there, it found the split. Okay, now these are south and south. Look, blue sticking out, blue sticking out. Those fields are crossing right here. With enough space, they cross. So it's like north, south, right? There it is in the middle. You see how it switches here? But right here, because this one's north, this one's north, this one's north, this one's south, south, south. Watch here. It does not go in. It stays completely separated. It will not. It'll point here. It'll point at the other one here. But it stays level. Unlike this. See this? See this? See this? Okay. Now that you see that, when I made the big rotor and I put it half north, half south like my last one, which this one would only spin half north, half south, this one would not spin, or that one would not spin half north, half south. And when I put the magnet up there and I seen it doing the north, south, and then the split right here was nothing, I knew what was going on. I also did something else, and I'll show it in another video. Right now, again, this is just, I should make more videos, and I've learned so much experimenting that I find myself neglecting videos like I should. So I'm trying to do something better here and catch it back up. So anyways, north, south on that, even though half of them are north and half of them are south. So I went ahead and went north, south, north, south, north, south. And you do get the full north split by south, split by north, okay? So it's completely split. This one will not even shake, will not even move over this thing when it's in here, north, south, north, south. You can't even feel it vibrate. This one, on the other hand, north, south, will sit here and spin all day when I put them up here. But let me show you one thing else. It doesn't just spin any which way you do it. So another thing is everybody says they don't know where the split is on these. There's no split. There's no way to do the timing, which side, you know, in motors, if you make an electric motor and you make all these armature arms, you don't know which side, you know, you're doing the timing around. But here, they don't have a way to time it. They're actually full of shit. I took a magnet, one of these big magnets, and I held it this way, just long ways up and down like this, because this thing always wants to try to flip the magnet like this. And if you lay that magnet in here and you turn it this way, this whole coil will sit here and shake from the field. And as you turn the magnet, you'll find a spot where this coil's shaking, and then all of a sudden it don't shake. Now you'll still feel your magnet kick left and right, but you're not shaking this coil from the field bouncing around, which tells me there's your dielectric plane that splits. So mark it. You need that, and I'll tell you why you need that. When you pull this guy up in here and you put him in north-south, north-south, it will not spin this thing because it alternates left and right here. Put this guy in here like this, and he'll spin that rotor. I'll show you that video coming up. Now, I just wanted to show the coils here. When I originally did this guy, and I put him in here. One second, I'm gonna put this down. Well, I don't think I can hold it. Oh, I'm gonna put it down. Okay, I'm back. So, you see how he spins. And then I put these little coils on the outside here. They're series together. And then I took my two leads and I ran them to a DC or to a full bridge rectifier, and then ran this, and I only got a few volts. It wasn't much. And the problem is because the magnets are real weak in here. Actually, got my big neodymium ball. If you look in my other video where I'm spinning it, and I made a little 3D printed thing that just hold it in spot. And I put this here, and I put the neodymium block on it. Then I put that on top and taped them together and stuck them in here and spun it. And I could pretty much break even on my charge, even actually make more charges on a second battery, but I couldn't charge my first battery, and that is for a whole nother subject and topic I'll tell you in another video. That's the over unity breakdown that everybody doesn't understand. You need to go look at wiki and look up cathode and read about cathodes and which way current flows on a battery charging versus a battery that's being used to power something. The negative and which way the current run is the opposite. One charges one way, one splits the other. So you're not going to take a battery and push it in and use it out at the same time in any of these type of systems, because if you're trying to push in and push out at the same time, you're trying to push north and north together, and north and north will always fight. So what you find is like a hydraulic lock deal. Basically, you know, I can start making as much power as I want and put more coils and make more power. As soon as I put it back to the same battery, it becomes a hydraulic lock. North against north, south against south, and it'll just sit there and never rise and never lose. What's interesting though is you can actually tap into those two lines that are stuck there and run it up to another battery, and it'll sit there and charge that battery. And your other battery will still never charge and never lose, or charge your iPad, or charge whatever you want to charge. You can charge that, and yet you never lose a volt on your other battery. Again, look up cathode on just wiki and just read the info. That's why I was having problems always going back to the same battery, but I can charge another battery 5 times quicker than I can drain the battery that I'm using to charge the other battery. So I believe that's what was going on there. Now, last thing I just want to do, because it's starting to get into a long video, this coil, our coils that we use in generators, we wrap big coils like this, we run the magnets by it. We get hit with Lenz's law, okay? It induces in the opposite, and what happens is our rotor slows down, and we need more to push through it, and it becomes harder to do. That's the second problem, okay? I can take these coils and you know, get 40-50 volts out of them, you know, AC alternating as it's rotating, run it to the deal, and you know, I get a decent amount of amps. When my rotor slows down, let's say I can run, you know, 120 hertz before I add these coils. When I add these coils, I can't get over 40 hertz, and that's because of that Lenz law acting. But if I get rid of that coil and I just put this coil on here, I went from where I could do 40 hertz with the same exact setup to using this one and getting 80 or 90 hertz. And that's because of the space. This wire gets induced is not close enough to this wire to cause Lenz's law to affect me as much. I'm kind of slightly mitigating it through this, and trust me, these picket magnets can reach well through this going around, so it works really good. I can actually, you know, 40-50 volts, I can get 100 and something volts with this and have a lot of amps with it too, light bulbs charge. And if I run it back to the same battery, it will only keep it the same. It'll still charge the other batteries that are in line hooked up to it, but it will only, since the battery I'm using has got it coming out, it will not go in there. It just levels it out. It just like hydraulic locks it. It's weird. Anyways, hopefully that gives you guys an insight to some of the coils or the rotors and coils I've been doing and playing with. I use these guys to spin it. I use these guys for pickups, and I just use this little bitty 20 watt amplifier. You can plug 12 volt power right there from a battery, and you can just plug your iPad in right here and do your just get you a frequency generator app and use it. This is just soldered on here. It had a little one, but it broke off, so I just did a different one. It's just a 1K pot. It's my volume, but nothing special, guys. Nothing great, but it is the cathode thing. It was a big thing. Learning how batteries work when they're being used and what the chemical reaction happens versus when they're being charged. It's totally opposite way the current runs. So that's the OU breaker. That's why you need two batteries. You need one to use and one to charge. You can switch them out. 3 would technically be even better, but I'll get into that setup later. Again, just insight, guys. Don't know if it helps you. Don't know if you care. Here it is.